Alright, here we go. Let's continue now with our lecture in topic 4. Lecture 2. Oh boy. And don't worry about the shaded lectures that you see here. But we talked about a medium temperature lab. And now, guys, I want to make sure that you have access to the Google Earth. So you'll see here, you click on the Google Earth, and if you don't have Google Earth on your computer already, please come in and go to the Google Earth Setup Executive, and that'll download for you. Then, if you have questions about that, you can ask me personally or talk to your computer tech about it. But then you've got to install it in your computer if you have those administrative privileges. And then you end up with Google Earth. And you'll have a little icon here. Great tool. Okay, so if you include this earthquake, the different layers here, USGS magnitude, there we go. So if we take a look here, it doesn't look quite right. It's off, tilted off or something, isn't it? See, I can change the orientation here. Let's make this big. Okay, that says true north right there. That looks better, doesn't it? It was kind of weird before. Let's take a look here at we've got our tectonic plate boundaries incorporated now. Earthquakes checked. So you uncheck that box, all that stuff disappears. You check the box, real-time earthquakes, and you get your earthquakes past hour, past day, past week, and this magnitude, your time frame up here. And then the tectonic plate boundaries, this is what's important for us for the next quiz coming up. And if we take a look here, you can see the different tectonic plate boundaries, or the ring of fire. Let's go on down and take a look at it. Now, just kind of off the track for a second, see all these scars out here? I don't know if this is a photographic issue or if that's where the subterranean, yeah. Oh, it could be planes flying, you think?
No, pipelines.
Oh, pipelines. Oh my goodness sakes. That's a thought, huh, Tanner? That, buddy, it's always good to have some other input. I had never thought about it. Maybe it is. Let's see, where do they go?
My brother worked in the Gulf, and it's like a spaghetti bowl of pipelines down there.
See, this is the Hawaiian Islands, right? By the way, the Kilauea on the large island. Let's see if we can find it. Kilauea. This is not a current picture, by the way. And I also have the Voyager down here. If you look over here, if you can see my pointer going to the left-hand panel, you see here's your Voyager, which is a satellite image as opposed to just a enhanced digital image. Okay, here's the observatory right here. These are pretty cool. The Kilauea itself, that's... Anyway, kind of off track here. But this is a magma plume out of the core of the Earth. That's one of the largest plumes that we know of in the world, outside of the one that's right here in Yellowstone. But I was looking at those weird lines, and Tanner said, hey, maybe they're pipelines, but it seems to me like they're kind of converging into the Hawaii, unless it's just some kind of a photographic issue. But what we're concerned about for our tectonic plates, you see right along the edge of the United States here? See, and you see right here this arrow is indicating 39 millimeters per year of subvergence. So this is subversive fault right here. This blue indicates subduction zone. If you look over here once again on your left-hand panel, this blue line is reflective of a subduction zone. And that's when one plate goes under another. So we have the continental plate here, the United States, North America in general, and then the Pacific plate. Pacific plate's coming in and going under, and this is where the tectonic interface, the continental plate, and we're going to take a look at how that bulldozes up the shape of this arcoidal shape here in the west coast. Then if we take a look a little further out, aha, here we've got this oceanic transformal interface right here. So you got a subduction zone coming in, transformal zone, and we're going to talk more about what a transformal zone is here. And then we got this oceanic continental transformal. This is oceanic converging, oceanic spreading. Okay, so this whole thing, I don't know if these ripples are true to scale or not, but those look like a stress issue right there to me. And so basically this whole thing is moving in underneath the continental plate. And this is just a sub. But you might notice it looks kind of like a staircase. So we got a transformal, oceanic spreading, transformal, oceanic spreading, transformal. And then it goes on up and comes out through the Aleutian Islands. Then it goes on down San Andreas Fault, right along the edge here. So once again, if we take a look at this now, as we zoom in on it, this transformal and then this oceanic spreading. And then the subductive fault right here, subduction zone. If we can take a look here and see what the San Andreas Fault is all about. You see where it runs right along the coast here. Comes inland up there by San Francisco. On down through the California area here. And then we got a continental convergence right here, you see it? Off to the left, the white continental convergence. And we, once again, we're into a combination there. Salton Sea right here, which is, by the way, one of the largest areas. It has a very good geothermal production facilities down here. Take a look at. So we've added a few more places now over here. And you can see that in the places down here. Opened up. Some of the tours will take in just a minute. But the idea here is if we take a look at the primary database, Voyager, borders and labels and places. Okay, so here we are taking a look at that San Andreas Fault coming on down through Davis Shrimp Seep Field in the Salton Sea. And then that tectonic interface, that subductive, transformal, continental plate convergence comes out, the San Andreas Fault comes out into the Gulf of California. You can see it right here. Comes out the bottom of the Salton Sea. Then we've got this continental convergence. See it right here, the white indicates a continental convergence. But it's underwater. Interesting, huh? And then you see the red, oceanic spreading going on up here. Transformal. Okay. What's important is that you see how this stair-step interface, tectonic interface, and you see how it just runs out the bottom of the Baja. You see how it's just cracking right on along here through the Gulf of California. And look what happens as it comes out the bottom of the Ring of Fire way down here. Take a look at it coming out. There's Brant's Cormorant diving for fish. Cabo San Lucas, huh? Cabo. San Lucas Canyon. Cabo San Lucas. There it is. Tip of Baja. We're interested in this tectonic interface right here. So you see the oceanic spreading, and then look here, the pink, oceanic converging. So there's a convergence going on right here, huh? Oceanic converging. And then once again, subduction. And you see how that is the Pacific, the edge of the Pacific Ring of Fire. And we're going to look at that in more detail here in just a few minutes. But what's important is geothermal energy, happens along tectonic interface more so, huh? Let's take a look here at the Salton Sea. Let's take a look at some controlled thermal resources. Yeah.
It's full of mercury, arsenic, selenium. It's full of it.
The largest impact, of course, will be dust. The cost of not doing anything could be in the tens of billions of dollars.
We are screwed because 20 years ago, not enough people were thinking 20 years ahead.
Little by little, the Salton Sea is disappearing. California's largest inland body of water used to cover where I'm standing.
But right now, it's receded so far behind me that I can barely see it. And disaster looms on the horizon. Toxic dust is getting kicked up, and the communities nearby are suffering from alarming rates of asthma. And kids are some of the most vulnerable.
You let that sea die, we're gonna die with it. This is not a joke.
This area already looks like Mad Max meets Timothy Leary. Gutted communities, burping mounds of mud, and piles of dead fish along the beaches. But it didn't always look this bad.
In 1905 and 1906, the Salton Sea was created by accident when the banks of the Colorado River broke and flooded it. At the time, people thought that the lake was just going to evaporate and disappear. But what ended up happening was that it was fed by water like this that was runoff from farms in the nearby area.
Back then, water was so plentiful, it seemed like a good idea to turn a desert into farmland. Today, farmers still flood their fields, and agriculture has grown into a $1 billion a year industry. The water also drew people. It's hard to imagine now, but in the 50s and 60s, the sea drew more people than Yosemite, including Hollywood's glitterati. Now the nearby towns have been whittled down to die-hard locals and the curious.
Charter boats for fishing and water skiing and just hanging out and having fun. And it's a beautiful, beautiful area.
My first husband and I were on our honeymoon. There was like 7 restaurants and drinking establishments on the beach. It was beautiful. This was a really fun place to be.
If I brought my wife on our honeymoon here, she'd divorce me.
Yeah, well, it probably.
It looks a lot different now.
No, it's extremely different.
The good times could only last so long. As Southern California grew, so did demand for water from the Colorado River, which sustains cities throughout the Southwest, as well as farming here in the Imperial Valley. These farms pull more water than anyone else, and the cities wanted a bigger cut. In 2003, San Diego agreed to pay these farmers millions for their water. The deal also required the state to come up with a plan to save the Salton Sea. Problem is, they haven't, and in 2017, the tap to the sea will shut off.
We don't have the inflows of water that we had before. I think it is a dire moment.
With time running out, in mid-2015, Governor Jerry Brown appointed this man, Bruce Wilcox, to find a solution California could afford.
Everyone wanted the perfect solution to the Salton Sea, and there isn't one. Living close to the Salton Sea, if nothing is done, if no management is implemented, is going to be a tough deal. And it's going to get worse as the sea declines.
Not to play the blame game, but was the state doing enough before?
I don't think anybody was doing enough before, including the state.
When the wind blows, it picks up fine dust like this from the top of the exposed playa, and many worry that that's why the rate of asthma here in the area is 3 times higher than anywhere else in the state. Experts fear that 100 square miles of playa, or dry lake bed, could be exposed within a decade. In 2014, local students headed to the state capitol to urge lawmakers to take action.
My little brother has asthma.
What else is good about this?
I hope that air quality.
G101, volcanic eruption possible, abandoned seaside town, and then look it over here. Salton Sea documentary. Lecture 1, topic 4, by Jonathan Bowe. Whoa. Anyway, let's see what Tesla has to think about, or what Tesla has to say about this.